Hey, everyone, sorry for the late video. There was a lagging issue with the first time I made the video for my geometry class, so I had to reset my computer, and there was a bunch of headaches. So, I'm still here, whatever. I still promise you a video. Now, I posted along with a review sheet two videos that cover up the first two, like the first packet I gave you. I'll print out this packet. I know on the top of the packet, it's going to say pre-algebra. The only reason I'm using the pre-algebra packets is because it's more equal to what I expect from this section. For the algebra packets, they're like more than what I want, so I don't really care for that. The thing I don't think this is in this packet is permutation and combination, so I'll talk about that then. All right, let's go through this. So first off, I want the probability of getting a 12. So there's only one 12 on this wheel. So I'm going to do 1, because this is how many winning options I have, over the wheel in total, which is 16. So I'm going to do 1 over 16. And that's my final answer. Greater than 7. Remember, greater than 7 does not include 7. So that's going to be 8, 9, 10, 11, 12, 13, 14, 15, 16. Count that up, you should get 9. So 9 out of 16. Now the probability of it getting shaded. So the shaded is 16, 15, 14, 13, 12, and 11. So in this case, it is 6 over 16, which is 3 over 8. That's simplified. Now, let's say in the world you're scared in the test and you don't know how to simplify. Put the fraction you had first, which is 6 over 16. So 6 divided by 16. And then you're going to click the math button over here. That's underneath the green alpha button. And then you're going to press enter, frac, and then you're going to press enter again, and you should get the simplified version, 3 over 8. So if you want to simplify something, you can always use that. Remember, it's multiple choice. So this is the answers that will show up in the multiple choice, not 6 over 16. All right, find a prime number or a multiple of 4. So a prime number is a number that only multiplies to itself. So that's going to be 2 and 1, 2 and 3 and 1, 5 and 1, 7 and 1. 9 is 3 times 3, so that doesn't count. 11 times 1, 13 times 1, 15 has 5 times 3, so that doesn't count. So in this case, it's 1, 2, 3, 4, 5, 6 prime numbers. But I said or, so I also need a multiple of 4. So multiple of 4s are things that 4 multiply into. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20, but that's too big, so we don't care about that. So in total, we have 10 numbers that fit this situation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers that fit the situation over 16 numbers on the wheel, which we could simplify to 5 over 8. All right. This one is using the wheel from above. It is the probability of getting the spinner 100 times. So this is rolling 100 times. Make sure to read the little paragraph there so you don't have to add up all the numbers. Remember, what does this table actually saying? This table is saying the number 8 I got 9 times. The number 7 I got 4 times. So remember, the number on top does not really represent, it represents what you got, and this represents how many times you got it. So if I ask you how many times did I get 14, this is 14, I got it 8 times. All right, so for this part, it says compared to a theoretical probability. You never do that. Based on the experiment, what's the probability of spitting an even number? So what I should do is add up all the even numbers. So 2 is an even number, so I'm adding 4 to it. 4 is an even number, I'm adding 10. 6 is an even number, I'm adding 7. 8 is an even number, I'm adding 9. 10 is an even number, I'm adding 6. 12 is an even number, 7. 14 is an even number, 8. 16 is an even number, 3. So I'm adding these red circled ones because that's how many times it happened. So it's going to be 54 over 100. We're going to simplify to 27 over 50. You don't have to compare. But if you want to know, you're a little bit luckier than what you theoretically should expect. You're a little bit more than half. All right, next one. Based on the experiment, what's the probability of getting at most 12? So getting at most 12 means 12 or more. Is 12 or less. Since 12 is included at most, I could have at most $12. I could have actually $12. so 12 is included. So these are the numbers I'm adding together. Everything below 12, 12 and below, I guess you're saying. So in this case, it's going to be 80 over 100, which is going to reduce to 4 over 5. Again, you do not need to compare. Theoretically, so since I said theoretically, pay attention to that. What's the chance of me getting, if I spun 250 times, of getting an even and a perfect square? So previously we said or. So when you or, you add it together. Even and a perfect square, they both have to be true. So first let's talk about evens. That's 2, 4, 6, 8, 10, 12, 14, 16. So those are evens. And then let's talk about perfect squares. Remember, a perfect square is a number that you could square root and has a clean number. Or another way you can think about it, something like 1 times 1 is 1. So that's a perfect square. 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, but that's outside the wheel, so we stop there. Now, I want and. So even and a perfect square. So I only could take numbers that have both tick marks. In this case, this is number 4. So that's 10 of them. And number 16, which is 3 of them. Since I'm asking for theoretically, I'll only have 2 numbers that fit this rule. So that's 2 out of 16 because there's 16 numbers in total on the wheel. So you might want to just look at this part, I guess. So 2 out of 16, and I'm going to times it by how many times I spun it, which is 250. So 2 divided by 16 times 250 is going to be about 31 times. Okay? It rounds to 31, okay? This one, based on the experiment, now I look at these numbers. So 10 plus 3 is 13 out of 100, and I times that by 250. So in this scenario, this would be about 33 times. Okay. All right, let's go to the next one. The table shows Tom's last 4 rounds of, or 72 holes of golf. Okay. Based on Tom's record, so 72 holes in total, by the way, so this should be an add up to 72, find the probability that he gets a birdie on his next hole. So what's the chance of him getting a birdie? Him chance of getting a birdie, he has 18 birdies out of 72 in total, which means the chance of him getting a birdie is 18 over 72, which reduces to 1 over 4. So he has a 1/4 chance to get a birdie. If Tom plays 12 rounds, or 216 holes, of golf this summer, how many times do you expect him to par the hole? So in this case, we're going to look at par. So par is over here. This is 32. He 32 out of 72 times, he pars the hole. But we're saying he does it 216 times. So I'm going to do it times 216. If I multiply that and do the math, that should be 96. So I expect him to do it 96 times. All right, next one. Okay, students who buy their lunch from this nonsense, you could choose from a ham, turkey, or grilled cheese sandwich. So notice that's 3 choices. So I'm going to put 3 here. For a side, they could choose fruit, yogurt, or a salad. That's 3 choices. So I'm going to put 3 here. For a drink, they could do juice or milk. So juice or milk, that's only 2 choices. So when you're making choices on different categories. So in this case, it's sandwich, side, and drink. I do the multiplication. So 3 times 3 times 2 is going to be, what's the chance of getting one side, one drink, one sandwich, one side, one drink? I just do 3 times 3 times 2, which is 18. How many raffle tickets are numbered possible if it contained 2 letters followed by 3 digits? So there's the first 2 letters. So I have 26 options for my first letter, and then 26 options for my second letter. And I have 10 options for my first number, 10 options for my second number, 10 options for my third number, because it's from 0 to 9. You multiplied all that, that's 767,000. All right, Sarah picks a card at random from a standard deck. Okay, you will not get a deck question on your test. Don't worry about it. Doug decides to guess his last 3 multiple choice questions on his science test. If each question has 4 choices, how many ways can he answer the question? Since he's doing 3 questions, that has 4 options. That'd be 4 times 4 times 4. Because the first question, he has 4 options. The second question, he has 4 options. And the third question, he has 4 options. By the way, that's the same as 4 to the third power. Either way, your answer is going to be 64. All right, look at the spinner. Please look at the spinner carefully on the test. Sometimes they repeat the word, so you see multiple blues here. So don't get tricked up by that. All right, if the spinner is spun twice, so we're going to do 2 things. What's the chance of me getting a red and then a green? Well, in reds, there are 1, 2 reds on the spinner. So that's 2 over the amount of sides on the spinner, which is 8. Times the green, which is, in this case, 1. There's only 1 green on the 8 sides, so 1 over 8. Which means it's going to be 2 times 1 over 8 times 8, 2 over 64, which simplifies to 1 over 32. Remember, you could use your calculator to simplify. Yellow, then blue. There's 1 yellow, so 1 over 8, times blue. So that's 1, 2, 3, 4 blues, so 4 over 8. That's going to be 4 over 64, which is 1 over 16. Blue both times. So the first time I get a blue, that's 4 out of 8. The second time I get a blue, that's also 4 out of 8. So that's 4 out of 8, 4 out of 8, 16 out of 64, which is 1/4. All right, there are 13 girls and 15 boys in the math class. If the teacher chooses random and then rolls a standard die, what's the probability of choosing a boy, then rolling a number that's most 4? So first off, there are 13 plus 15. In this class, they have 28 kids in total. So 28, the chance of me picking a boy is 15 out of 28, times the chance of getting at most 4. Remember, at most 4 means 4 or less, because I can't have at most $4. I can have a smaller amount, but I can't have more than that. So that's 1, 2, 3, and 4. So 4 over 6. That's end up going to be 60 over 168, which is going to be 5 over 14. Again, don't be afraid to use your calculator to simplify. All right, Karen is flying from Orlando to Baltimore, then Baltimore to Boston. The first flight has been delayed 6 times in the past 14 days, and the second flight has been delayed 8 times in the past 12 days. What's the probability that both flights will be delayed on the day that Karen flies? So we know the probability of the first flight being delayed is 6 out of 14. So 6 out of 14 times. The second one has been delayed 8 out of 12 days. So 8 out of 12. So 6 over 14 times 8 over 12 is 48 over 168, which is 2 over 7. Again, don't be afraid to use a calculator. Next one. A piggy bank contains 4 pennies, 6 nickels, 10 dimes, 5 quarters. A coin is drawn at random, not replaced, that's important, and another one is drawn. What's the probability? So first off, we just want to make sure if you count the coins, it's 25 in total, okay? There's 25 coins in total. 4 plus 6 plus 10 plus 5 is 25. So what's the first chance of me getting a nickel? So there's 6 nickels, so there's 6 out of 25. Then a quarter. Now, I did not replace the coin. So did I not put it back in? Because I did not put it back in, I have 1 less coin in the bag or the piggy bank. So there's 24 on the bottom now. And that's going to be times a quarter. I didn't reduce the amount of quarters. I still have 5. So it's going to be 6 times 5 is 30. 25 times 24, that's 600. So 30 over 600 is 1 over 20. All right. What's the chance of me getting a penny? So there's 4 pennies out of 25. And not a dime. So not a dime. If there's 10 dimes, there must be 15 of other coins. But keep in mind, I took away a penny. So I have 1 less coin. So it's 24 here. And not a dime is pennies are included, not a dime. So even though normally there's 15 not dimes, I in this case only have 14 not dimes because I took 1 penny earlier. So with that in mind, 14 times 4 is 56 over 600. That's going to be 7 over 75. All right, the probability of both dimes. So the first chance of getting a dime is 10 out of 25. So the second chance of getting a dime, I have one less coin in total, 24, and I have one less dime in total, so that's 9. So it's going to be 90 over 600, which is going to be 3 over 20. Both nickels. So in this case, it's 6 over 25. I lose a nickel because I picked one already, and I lose a coin in total because I picked the coin in total. So this is going to be the final answer, 1 over 20. We've done this kind of multiplication earlier. Okay, next one. Mean, median, mode. I'm going to do just one of these because after I do one of them, they explain each one. But mean, median, mode. So this is the numbers I have. So the first thing I should do is put it in order. So I see a 36, another 36, and then a 40. Then I got a 42, a 43. I got a 52. No, I got a 45. And I got a 52, 52. And then a 59. Okay. All right. So first off, I want the mean. To find the mean, I'm going to add these up all together. So I add 36 plus 36 plus 40 plus 42 plus 45, blah, 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 blah. So that's 405. And I'm going to divide it by how many numbers I have. So to have 1, 2, 3, 4, 5, 6, 7, 8, 9, I divide it by 9. So 405 divided by 9 is 45. So the mean is 45. Now the median, I want the middle of the numbers. In the middle of numbers, I count from the outside in. So I'm counting from the outside in. In this case, I only have one middle number, which is 43. Reminder, if you have two middle numbers, you just add the first number plus the second number and then divide it by 2. You get the average of the two numbers, if you have two middle numbers, okay? The mode is the thing that happens most often. It looks like 52 happens twice and 36 happens twice. So which ones gets to be the mode? They share the reward. So 36 and 52. And the range is always biggest minus small. So big minus small, or largest minus smallest, doesn't matter. So 59 minus 36 is 23. Again, I'm not going to do this a bunch of times. You get the concept. You do not need to do this. Don't sweat that. This one, they say a 5-number summary. This is the box and whisker plot. Usually minimum, I show lower extreme, and the maximum is upper extreme. But that both works the same. So for the box and whisker plot, we first want to put it in order. They did not give it an order. So let me put it in order. 36. Yeah, let me type it out so it's nice and neat actually. 36, 54, 60, 68, 72, 78, 82, 90, 95, 110. Okay. All right. So first we want to figure out the middle. So the middle, we're just going to count from the outside in. And in this scenario, we have two numbers in the middle. So there's two numbers in the middle. So the number in between 72 and 78, 72 plus 78 divided by 2. That's going to be 75. So that is 75. Okay. Now, I'm going to have to find the middle of the first half. Oh, let me put that 75. 75 goes here. That's the median. Now, I want to find the middle of the first half. That's going to get me the lower quartile. So the middle of the lower quartile, remember, 72 is not the middle, it's 75. So 72 is part of this data. So in this case, it's 60. So the lower quartile is 60. And if I look up here, the lower quartile here is 90. One way to check quickly if you did it correctly, or you know you didn't do it incorrectly, is that if there's a one number in the middle of the lower quartile, there should only be one number on the top of the upper quartile, okay? So if you have two numbers in the middle of one half, but one number in the middle of the other half, check your middle. You messed up somewhere. All right, and the maximum and the minimum, or the lower extreme and the upper extreme, or just the big and smallest number. So this is 36, this is 110. So 36 is going to be over here. That's the smallest number I possibly have. And the maximum, or the upper extreme, is 110. I'm 90% sure I put numbers on your tests, so you don't have to worry about making the number line. I'm just make it right here. Let's make this 30. Let's make this, well, let's do this one. 35, 40, I'm not going to write 45, so 50, 60, 70, 80, 90, 100, 110. So make sure they all fit, right? So in this case, I'm going to put a dot at each point that I found of my 5 points here. So 36 is over here. 60 is over here. 75 is over here. 90 is over here. And then 110 is over here. Remember, it's line, then box, then box, then line. And remember, each piece is 25% of the data. So this is 25%, this is 25%, this is 25%, this is 25%. Okay? You get the concept. I'm not going to do it again. This one, though, is a good question. It's like comparing them. All right. These are two things. They're two neighborhoods. In the last 8 years, 8 homes were sold in Wander Crossing and 12 homes were sold in Kingston. Each home had different prices. This is the box and whisker plot. All right. Which one had the greater interquartile range? So interquartile range is the range of the box, so how big the box is. So this box is 240 to 210. So 240 minus 210, that's 30 wide. While this box, and you can basically see because the box is literally bigger, you don't have to even do the math really, but this is 240 and this is 190. So this is 240 minus 190. This box is 50 big. So in this case, which one has the greater interquartile range? In this case, this is the bigger one, so Kingston. What's the difference between the median price of the two neighborhoods? So the difference, remember, is a subtraction problem. The median is the middle of the box. So I'm looking at this number, which is 230, and this number, which is 210. So 230 minus 210, that gives me 20. What percentage of the home is at least 240K? So what percentage is at Waterstone, at least 240K? So remember, each section here, no matter how big or small, is 25%. So this is 25%, this is 25%, that's 25%, this is 25%. Since I want at least 240K, I want anything bigger to 240K, which is only this part, the straight line on the outside, so that's 25%. In this one, how many homes were in the two neighborhoods sold for, what? How many homes in the two neighborhoods combined sold for more than 210? You will never have to do a question like this. Don't sweat that one. All right. Line of best fit, we didn't do that, so you don't have to worry about that. Let's go to two-way tables over here. All right, two-way tables. Here's a Venn diagram. The Venn diagram shows the best survey results of the situation. Remember, a Venn diagram, in total, there are 28 people who did sports, and in total, there are 25 people who did part time jobs. The number on the outside means they did not do a sport nor a part time job. They did nothing, okay? So, the total amount of sports is 18 plus 10. So, 18 plus 10. The amount of people who did sports is 28. The amount of people who did a part time job is 10 plus 15. 10 plus 15 people who had a job is 25. Let's see. The middle is how many people, the middle right here, is how many people had a job and did sports. So people who had a job and did sports, that's 10 over here. And then this number outside is people who did not have a job nor had a sport. So no job, no sport, that should be 7 over here. And we could get the total by just adding up all the numbers. 18 plus 10 plus 15 plus 7. So that should be 50. From there, we could use the two-way table to figure out everything. 25 minus 10 is 15. 15 plus 7 is going to be 22. 50 minus 25 is going to be also 25. So 25 minus 7. Or you could do 28 minus 18, or 28 minus 10. That should be 18. So you could do 28 minus 10 or 25 minus 7. They're both 18. Okay. Same concept here. Let's try it out. This is 150. So 150 minus 48 minus 42, that will be 60. 48 minus 40 would be 8, because 48 plus 8, 40 plus 8 should be 48. I could do 54 minus 8 minus 28. That's going to be 18. Then 42 minus 18. That's going to be 24, because 24 plus 18 should be 42. And then I could add these up, and that would be 96. Okay? So how many 8th grade students do not have a cell phone? So 8th grade students who do not have a cell phone, in this case is 8. How many 6th grade students have a cell phone? This must have been in the past, because there's too many people who don't have a cell phone. How many 6th grade students do not have a cell phone? Oh wait, have a cell phone, my bad. So 6th grade students who have a phone, that should be 24. You will not need to do a relative frequency table, so don't sweat that. We just got the quiz. Okay. All right. Let's try to do this quiz. For questions 1 and 2, we're using this deck of cards. This is okay because I'm giving you numbers, and we're doing it 60 times. All right. Alex draws another card. Which statement is true about the probability of a spade based off the experiment? So in the spade, he got 16 spades out of 60 in total. So 16 out of 60, which reduces to 4 over 15. So 4 over 15, these are wrong. Now, which one do I expect them to be? Is it less than probability or more than probable? Well, 4 out of 15, if we return that to a decimal, I guess I'll use a calculator. 4 divided by 15, that would be 26. So 26.6. So 26.6%. The chance of getting a spade in a deck of cards is normally 1 out of 4, which is 25%. So he got it more than expected. So he got it more than theoretically. If Alex draws a random card 400 times, which of the following statements are true? That he should expect to get a heart or a diamond. So a heart or diamond, so 15 plus 9. So 15 plus 9 is 24. 24 out of 60 is going to be, well, actually, I don't care about 24 times 60. 24 times 60 times 400. That's going to be about 160 times, okay? Now, what do I expect, though? Because there's a theoretical. Theoretically, a diamond or heart, that's half the cards. So 1 over 2 times 400, that'd be 200. So, since I expect to get 200, but I really only get 160, I get 40 times less. So 4 times less than is theoretically expected. There are 10 sixth graders, 14 seventh graders, 6 eighth graders on the track team. How many ways can the coach choose 1 sixth grader, 1 seventh grader, and 1 eighth grader? So 10 times 14 times 6. Pretty straightforward. That should be 840. Next one. Kara, choose a random date in the month of June. There's 30 days in June. And the letter in the word mathlete. What's the probability the date is a multiple of 5, vowel by vowel? So first off, what's the chance of getting a multiple of 5? There's 30 days in June, so that's 5, 10, 15, 20, 25, 30. There's 6 numbers at work out of 30 days in June. And then what's the probability of getting a vowel? There's A, here's an E, here's another E. So 3 out of 1, 2, 3, 4, 5, 6, 7, 8. 8 words. So 3 out of 8, which is 18 over 240. We want to simplify that. That's 3 over 40. So D. Mitchell and Travis play basketball. Mitchell hits 5 out of 12, and Travis hits 9 out of 20 at bat. Based on their past performance, what's the probability both get a hit next time at bat? So we want to see if they both get a hit. So first off, Mitchell hits 5 out of 12, and Travis hits 9 out of 20. So we multiply those out. 45 over 240, which we could simplify to 3 over 16. This one. Caitlin draws a card but does not replace it. Not replace. And draws another. What's the probability both are going to get a star? So it's 1, 2, 3, 4 stars. So it's 4 times 10. And then it's going to be, I took 1 star away, so I need a star again. So I have 1 less star and 1 less card in total, so 3 over 9. So 4 over 10 times 3 over 9 is 12 over 90, which reduces to 2 out of 15. You don't have to worry about this kind of question. It just asks, don't worry about that kind of question. The data below is 8 speeds. Find the absolute mean deviation. You don't do absolute mean deviation. Don't worry about that. These are 2 box plots. I guess mark which is true. Okay. Class A has a greater lower quartile. Remember, this is lower extreme, lower quartile, the median, the upper quartile, and the upper extreme. It might be, say, max or min also. Same thing here, lower extreme, lower quartile, median, upper quartile, upper extreme. So Class A had a greater lower quartile. Class A lower quartile is bigger than Class B. Makes sense. Class B has a lesser median. The median is bigger than A, so no. A has a greater interquartile range. That would mean how big the box is. In this case, Class B has a bigger box, so no. B has the greater maximum. That's the upper extreme. That is true. A has a greater range. That'll be how wide this line is. So the range is here. So 95 minus 30, this would be 65. And this would be 100 minus 40, that's 60. So A does have a greater range. Both classes has the same upper quartile. This is the upper quartiles. They're both the same. So yes. So those are the true parts. Don't worry about this. Don't worry about this. Two-way table. Oh, that's an interesting one to do in reverse. So let's fill out the two-way table. There's 30 in total. 18 minus 3, that must be 15 people who said this. And then 12 minus 7, that's going to be 5 people who said this. 5 plus 3 is 8. And 15 minus 7, 15 plus 7 is 22. 22 plus 8 is 30. So that makes sense. Okay, so let's be careful. The people, we'll do the intersection first. So this box in the middle must be the people who said Canada and Mexico. So the people who said both Canada and Mexico is 3. That's over here. Let's just put that there. That's 3, okay? Then I want the people who said no to both things. Who said no to both things, both Canada and Mexico, is 7. So that's going to be out here. Okay? So this box over here is going to be people who said yes to Mexico but no to Canada. So people who said yes to Mexico but no to Canada, that should be 15. And this box over here, Canada's box, should be people who said yes to Canada but no to Mexico. Yes to Canada, no to Mexico, that's 5. And to check the work, you add that together. 5 plus 15 is 20. 3 plus 7 is 10. 20 plus 10 is 30. So that matches our total. Okay. One thing we did not have in this packet is just permutation and combinations. Just a reminder, if I have 6 factorial, 10p2, and then 10c2, how do we do that in our calculator? We go to the math here. Always put your number first. So I'm going to put 6 first. I'm going to click math. And I'm going to go to the option that says probability, so all the way to the right. And then the option here, 4 is the exclamation point, 3 is NCR, 2 is NPR. So if I press 4, that'll give me 6 exclamation point, that'd be 720. 10p2, math, we go over here. Oh, I got to put the number first, so 10. Then I go to math, put the number here. I want P, so that's option 2. And then 10p2, that's going to be 90. And then if I want C, so N, I put 10, put the probability, option C, so that's 3. And that's 2 again? Yeah, 2. So that's 45. So 720, 90, 45. So that's your answers. Remember, you could get that from a calculator. Remember, I use P when I care about order. So when I care about order are things like first, second, or third. So when I care about order is things that are like first, second, third place, gold, silver, or medal, president, vice president, secretary. Those are things where I care about. While C is where I don't care about the order. So I just want the finalists. I just want people on the council. I'm picking kids to get something from the office. These things I don't care. Well, these things I do care in particular. So P is particular, I care. C is I don't care. All right. Other than that, I think with the 2 videos earlier, that should cover everything. If you think I missed something, let me know, and I'll do another video for it.